Okay, so what's bothering you?
Moving from one point to another with no change in velocity.
Which number are you talking about?
Number
3?
three.
Oh, okay. I'm sorry. I thought you were still on 2. Dominic, you good with 2?
Yeah.
Okay. Let's take a look at 3. On 3, what you have to remember, a volt, that's like voltage. Volt is what we say for potential difference. That's a unit for it. But you have to remember that's a joule per coulomb. Long. Okay. And if it's a joule per coulomb, if we are taking 1 joule of work, needing to move 1 coulomb, 1 joule of work, 1 coulomb, we're not speeding up or slowing down. We're going at a steady pace. That means we are going to get a potential difference of 1 volt.
Okay.
And that one took me a minute too, because I'm so used to just thinking of plain old voltage. And like I said, it's really important to know what a volt's like a secondary name. You know what I'm saying? So,
Right.
so you need to kind of like how like a Newton is really a kilogram meter per second squared. You got to make sure that you know what a volt, if you get down to basic units, what it is, or a joule down to basic units, what it is.
Are we gonna have to know that for like amps and ohms as well, or is it mainly gonna ask about like?
Any of them are a possibility. I would kind of look through it, before the test, make sure that you know what's what.
I also have a question on
Yes.
11.
On which one?
11.
11.
The multi-choice. Yeah, I got the exact opposite answers.
Okay, so we got a multi-choice here. So, which of the following statements is incorrect? We have to choose 2. So, if I'm looking at this, if I have a R, I'm not even looking at the questions yet. I know this is just R1 plus R2. I'm just kind of thinking how stuff's going to work. And then to get the total equivalent, it would be 1 over R12 plus 1 over R3 equals 1 over R equivalent. So I'm kind of getting an idea what's going on here. So we want to know which ones are incorrect. The current in R1.
Oh!
Did you not read the problem, Dominic?
Oh, come on.
I'm gonna be honest, I did that initially as well, so.
Like a straw that broke the camel's back.
Well, at least that's all that it was. You got it right in the wrong way. I'm so proud of you. What other ones, y'all?
I didn't have a problem with any other ones, so.
Okay. Let's see, let's just jump down here. Any of you guys that don't have your things on, any of them you want to see? Be brave.
3.
3? I think let's do 3. I may have just done 3, but you may not have been on here when I was talking about it.
You did
So let's talk about 3 again. 1 joule of work is needed to move 1 coulomb. Well, you have to know, and I told you all from the beginning, potential difference or voltage is in volts. That's its units, but that's a secondary unit. And it's really 1 joule per coulomb. That's what a volt is. So if we want 1 joule of work needed to move 1 coulomb of charge from one point to another. Now, the thing with no change in velocity, that means it's not speeding up or it's not slowing down, because if it does that, it's going to change the voltage. So which of the following is true between those 2 points? Well, volt is simply 1 joule over 1 coulomb. So that's why your answer has to be D.
I got A.
You got it wrong.
But
Why'd you pick A?
Because the formula P equals IV, I substituted V for IR,
P equals.
making it P equals I squared R.
Why?
Because P would equal 1, and then I equals 1. I squared, or 1 squared is 1. So that would make R also 1.
Well,
mean resistance is 1 ohm.
So you've got, 1 joule of work. I think, honestly, I just went down to D and saw it, and I knew it had to be right. I really didn't think about this. Somebody want to talk to me about why A would be wrong?
Does it really mention power at all?
That's what I'm saying. I don't think I see anything about power. Now we have 1 joule.
All it mentions is your 1 joule of work and your 1 coulomb of charge.
Right, and what's the units for power?
Hang
tell you.
It's measured in watts.
It's in watts, isn't it? But what's a watt?
Joules per second. Oh, gotcha.
But you don't see anything on here about time either. So
Yeah.
I think the idea of using the PIV equation is probably just incorrect because we don't have a wattage, because even though we have 1 joule of work that's moving 1 coulomb off charge, there's no talk in there of time, of the time that it takes for that to happen. Does that make sense at all?
Yeah.
Now, if it talked about that, for sure, you would do what you did. Okay, but all we know, 1 joule of work, 1 coulomb of charge. I knew that a volt was a joule per coulomb. That's why I went straight to voltage. So I would suggest, if I was you guys, look up like if I came over here, let me get my board out of the way. If I came over here and my mouse go. And just came over here and said, unit for electrical power is a watt. Well, great. But what's a watt? You got to know that a watt is a joule per second. Now, is a joule a basic help me unit? So it says right here, the SI unit of work or energy equal to the work done by the force of 1 Newton when its point is 1 application moves 1 meter. So all we really care about for a joule is that it's just a joule. Look how they say that, the joule. And again, it is defined as the amount of energy exerted when a force of 1 Newton is applied over a display. So it's a Newton per meter. That's what a joule is. So make sure you know what's a watt, what's a joule, what's a volt, what's an amp in its most basic forms. Because a lot of times, if you know that, you can just almost just do like dimensional analysis and figure out what your answer's unit should be. And a lot of times that's all you really even need. And if you look over here it is in its most basic form. Kilogram meter squared per second squared. So while it's good to know that joule is the unit for energy, you need to know what a joule really means, I guess, is what I'm trying to say. How about that's calculus. Y'all don't want that. How about any other ones? If there's no other ones, I am going to jump off.
Can you do real quick? I'm a little confused on
Do-
LFB.
Which one?
Number 10.
Number 10. Okay, this guy right here. Okay, so let's just take a look at this. So I'm just going to kind of go through all 3 of these. I think there's value making sure you know how to do all 3 of these. The net resistance, the first thing I'm going to do is I'm going to say 1/6 plus 1/3. We've done this one a gazillion times, I think. Was that 3/6? Now remember, that's 1/R. So this, if I put these 2 together, would give me 2 ohms. Then my equivalent resistance for this system is 6 ohms. Am I right with that one?
Yeah.
Okay. So we know we got C for this one. Now the voltage across this resistor right here. There is a voltage drop. Now our current's going this way, even though we know the electrons are going that way. But what I'm going to say here is if I just had this, and then here's my battery, and there's my switch. This is my equivalent of 2. This one's 4. So there is a voltage drop right here. We know we have 12 volts. So if we have, let's go ahead and get our current of the whole thing. If we want our current of the whole thing, our current is 12/6. So our current is 2 amps. So if our current's going around here and we need this voltage drop right here, let me make that red. Voltage equals I, which we just said was 2, times R, which is 2. So this guy right here, he used up 4 volts. If he used up 4 volts, how many does the 4 ohm one use up?
8 volts.
8 volts. So even though we say the voltage is the same across these two, correct? Because they're in parallel, so the voltage is the same. There is a voltage drop over those pieces. So that's why my answer to that one is B. And what we had to do, we had to find this one first, and then we simply subtracted it from the 12 to get the 8 volts. So now the current in the 6 ohm resistor. So if they're in parallel, does the current add up? I'm asking y'all.
Yeah.
Do y'all agree? If we are in parallel, so to kind of review this again, your voltage is your voltage, is your voltage, is your voltage, is your voltage, voltage, voltage. Your current is the sum of all the currents. And your resistance is 1 over R, 1 plus 1 over, So that's everything that we know for parallel. So we know by the junction rule, we're going to have 2 amps going in here. So we need to have 2 amps coming out there. Do you agree with me?
Yeah.
You okay with that? So now what we're going to say, if we want our current in the 6 ohm resistor, I equals V over R. Our voltage is the same in both. We're going to have 12. We want it over the 6. And we're going to get 2. Now this is over, let me see what I do wrong here. Because it's saying it's B, isn't it?
Yeah.
What did I do wrong? Oh, I'm an idiot. How much voltage what was the voltage drop through there? Yeah, I used the wrong thing. So let me erase this. The voltage drop across this as an equivalent, we just come up with it over here was 4. So it's going to be 4 over 6, which is going to give you your 2/3, which is what your answer is. And if we did the voltage across the 3 ohm one, we would have 4 over 3, which would be 1/3. Add those 2 up, we get our 2 amps. So check what I did there. What I did there is the rest of this voltage went on. The rest of this voltage went on over to the 4 ohm resistor. The 4 volts right here is what these guys are using up. That's what the voltage drop is across this equivalent resistor. So notice both of them are 4 because that's the voltage drop across this piece of the circuit. You okay with that? Hello? Who else on here?
Yes.
Thank you, Scout. I don't think you're the one asking me that question, though, were you?
No, I wasn't.
No, I'm thinking it was, if I had to guess, either Justin.
Oh yeah, sorry.
Was it you? Ha! I was trying to recognize y'all. Are you okay with that then, Justin?
Yeah.
Okay. So any other ones you want to look at, make sure you understand how these work. Because tomorrow you're going to be given however many questions like are on here, probably 12 like they usually are. 10 multiple choice, 2 multi ones if I can figure out how to do that. And then some form of an FRQ. Okay, so the FRQ is probably going to be some kind of circuit thing, would be my guess. I haven't looked at it yet. Like I said, I'm not real sure how I'm going to do it. So, like those general problems you guys did back over here. If we look at, where's my material? Here it is. Okay, guys, I'm having a brain fart. Where's the stuff? Oh, there it is. It's down there, isn't it? If we're looking at these, we're probably looking at ones that are more down here, these general problems down here. Something along the lines of these type of problems is what I'm looking at probably for the FRQ. And I may give 4 different versions, and some of y'all have the same ones and some of y'all have different ones. So just be aware. that, you may have something like this and you have to answer all those questions for it. So make sure that you can do these problems. Okay. Anything else for me then? Gosh, you go with that.
Nope.
Okay, well then I'm going to go ahead and stop this. I'm going to attempt to get these on YouTube. I'll go ahead and post it on Google Classroom. But like I said, I just don't think they're working right. So I will. Yes.
With YouTube, like uploading stuff tends to take a long time.
Right. Right. So I'm going to see how that works too. So we'll see how it goes. I mean, we're all just kind of figuring this out still right now. Okay.
Yeah.
Okay. Well, I will. If y'all need me later on, holler at me. Okay.